Friends, engineers, consultant engineers, architects, and students of architectural engineering going into MEP classes. Once again, this is VK Jain in this series of electrical switching devices and switchgears. My credentials are shown below, and I shall be discussing electrical switching devices in detail. Friends, for understanding the role of switchgear in total electrical installation, I have framed this figure which illustrates that starting from generating station through conductors, that means conductors taken on transmission line. These conductors may be AC, SR, or all aluminum type of conductor from this one, and these conductors uh, are taken further into electrical installation through a circuit breaker, of which we'll understand what is the role. Then we get buses in the form of conductor, and through conductor once again the circuit breaker installed before first circuit breaker, first transformer after generating, and this is a transformer which uploads from 11 to 13.6 kV to the transmission voltage, which may be as high as 400 to 750 or even 1100 in DC circuits. Once again, after the transformer, they are loaded to transmission line through circuit breaker. So you can see right from generator up to load, we get circuit breaker at many layers, at many places. Uh, so let me repeat. The above is a basic one-line diagram of complete electrical circuit, of which the basic components are generator, circuit breakers. These circuit breakers could be any switching device in switchgear like 11 by 33 kV VCB, 430 volt ACB. They are available up to 2000 kilowatt. Then MCCB molded case circuit breaker up to 400 kilowatt they are available, and MCB up to 40 kilowatt. 11 kV oil fuse switch unit, combination switch fuse unit, reliable fuse switch, 6 by 16 ampere piano type switch, 5 ampere toggle size. All these type of the circuit interrupting devices. I should say circuit interrupting devices. Then conductor is the third element, and they may be of ACSR, aluminum cored steel reinforcement, or all aluminum conductor. Both are used heavily in transmission line and distribution line up to 11 kV. We use copper, aluminum, or copper cadmium wires in medium voltage installation, and we go through an armored cable up to 400 kilowatt, and beyond that we take shelter of the bus ducts, especially designed to cater the higher kilowatt systems. Next is transformer, and The last is load, which may be purely resistive like heater or maybe majorly inductive uh, ma- motors, and maybe purely or majorly capacitive load in power factor panels. Bus bars are used at number of places, and they are heavy duty conductor bars that distribute power within the switchgear assembly. The classification of voltage. Switchgears are categorized based on amount of electricity they handle. Also based on voltages. Low voltage up to 1000 volt found in residential building, offices and small factories. That is your home's breaker panel. Medium voltage 1 kV to 36 kV used in large industrial plants, hospital and local distribution substations of office buildings. Beyond 3 MVA. High voltage above 36 kV found in power plants and utility transmission grid where massive amount of power travel long distances. Friends, the term switchgear, commonly used in association with the electrical power system or grid, refers to combination of electrical disconnects and or circuit breaker used to isolate electrical equipment. It is used both to allow work to be done on equipment safety and to clear fault downstream. Switchgear is located anywhere that isolation and protection may be requiring. These locations include generators, motors, transformers, substation, and high or medium distribution network. Switchgear of all types may be used by power utility, that means electricity board, as protection against line to ground, phase to phase, or line to neutral faults. Switchgear is also used for heavy industry purposes. High or medium voltage equipment may be required for industrial processes, and switchgear is used in these locations to isolate and protect the equipment. When you take a look inside this switchyard, you will see a bank of bus bars. Bus bars, which are generally bare and supported by insulators, are wide strip copper that connect to switchgear. Alternatively, we may use aluminum also, but below 10 MVA capacity systems. The busbar act to allow passage of large electrical current through the switchboard. Friends, the main functions of switchgear are: first, electrical protection; second, electrical isolation of sections of an installation, so that after that people may work safely on electrical system without getting any shock. Third, local or remote switching. Electrical protection at low voltage is, apart from fuses normally incorporated in circuit breaker, in the form of thermal magnetic devices and or residual current operated tripping devices. Less commonly, residual voltage operated devices acceptable to but not recommended by IEC. In addition to these functions shown above, further functions may be for over voltages, that is more than 25% of the rated capacity, under voltage protection, once again below 125% of rating capacity. Short circuit protection. Short circuit protection is normally taken as 7 time full load current capacity, and open circuiting, and in case of fall earth fault protection. Friends, the switching devices can be either isolator or contactors or fuse switches, that is switchgear with fuses, or circuit breakers. Isolator and contactor are the switching devices which can be operated without load. And the contactors are remotely operated with the help of a relay. Fuse switchgear were previously used with rewirable and HRC fuse units, and which were every time requiring replacement of fuses in case when short circuit happens, they are blown. Last two categories can meet circuit only if load is healthy, but out of them, circuit breakers are the devices used to make the circuit without getting damaged even in case of circuit, but for limited time and number of operations. So that becomes the definition of circuit breaker. Switchgear are also essential, a type of electrical distribution device that is used to convert incoming electrical power into several smaller voltages. Switchgear can also be used as a circuit breaker. First in the switchgear protection series comes the fuses. A fuse in its simplest form is a piece of low melting point metal which will open a circuit by fusing when current passing through it exceeds a predetermined value for a sufficient period. Melting or blowing of fuse is caused by the heat generated due to passing of current in the resistance of the fuse. Fuses may be of silver, copper, or lead tin alloy. All type of fuses will have inverse mm, current time characteristic nearly at square rate. Complete set of fuses in three parts. One fuse wire, second fuse carrier, and third fuse base, which has provision for sighting of fuse carrier and incoming and outgoing wires. Current rating of fuses. If it is the value of current which can flow through the fuse at rated voltage continuously without causing any hot flow in the metal. Fusing current. It is also a ratio of minimum current at which fuse will blow to its rated current. Fusing factor will always be more than unity and about 1.9 to 2 for rewirable fuses and equal to 1.4 for the standard duty cartridge fuse. Friends, now we'll discuss about HRC fuses. They were used uh, previously about 10 to 15 years ago in bulk, but their cost was higher, so they became absolute, and MCBs and other type of circuit breaker took the place of HRC fuse. These are called high rupturing capacity fuses as their breaking capacity is of the order of 80 kiloamps. HRC fuses are cylindrical in shape and of ceramic body filled in with filling powder of chemically treated quartz sand, which can absorb heat as a fast rate at a fast rate, and it does not result in formation of gas in any appreciable rate. Fuse element is a pure silver which melts at very high breaking currents and vaporizes. A high resistance substance is produced by the chemical reaction between the silver vapor and sand powder, which helps in quenching of the arc. After absorbing heat, quartz sand is converted into glass beads, which obstruct the path of restarting voltage. A red color indicating bead is provided to show the fact of fuse having blown. Now several type of HRC fuses are shown in the diagrams below. Friends, we will study about different type of circuit breakers deployed in AC electric circuits. We have one MCB miniature circuit breaker starting from 1 ampere to 63 ampere normally, but exceptionally up to 80 amperes. Trip characteristic normally not adjustable. These may be thermal or thermal magnetic or hydraulic in operation. Breakers illustrated above are in this category. Popular rating are 5, 10, 15, 20, 32, 40, 63 and exceptionally 80 amps. Next one is molded case circuit breaker. They are rated up to 800 ampere. They may be thermal or thermal magnetic in operation. Trip current may also be adjusted in larger ratings. Popular ratings are 63, 80, 100, 200, 250, 300, 400, 630 and 800 amperes. The next higher capacity is a circuit breaker. Rated current up to 10,000 amperes. Trip characteristic often fully adjustable including configurable trip threshold and delays. Usually electronic operating control, some models are microprocessor control. Often used for manpower distribution on large industrial plant where the breakers are managed in drawout enclosures for ease of maintenance. Popular ratings are 800, 1000, 1250, 2000, 2500, 300 and 4500. Friends, this particular chart shows recommended MCB for various common loads and residential applications. We use air conditioner of 1 to a half ton capacity. MCBs are deployed. Above that, MCCB are required in 2.5 and 3 ton capacity. We deploy MCCB in place of MCB. Refrigerator found in residential use are 150 and 285. In both cases, they will be 1.5 or 2 amperes respectively. Cooking range with oven cum griller are normally 4500 watt and they require 25 to 30 ampere rating. This one. So you can see from room heaters, washing machines, water heaters, irons, and electrical kettle and auto transformer. You can see the type of MCB rating here. Friends, about 30 years ago, this type of main switch were used for service connections and in main distribution switchboards of three phases applications. Uh, this will have three number fuse carriers. These are revariable type, and this shows the moving contact which moves from here to disconnection. This is the operating handle provided on the side. So it will disconnect these fuses and disconnect the further circuit going. Friends, switch fuse units are deployed heavily about uh, 30 years ago. This is a most simple type switch fuse unit in which fuses are inserted in between the fixed female contact, and switching action is incorporated by moving male contacts which can get inserted into fixed contacts by handle which is provided outside the switch unit. These are available. These were available in rating of 15/16, 13/32, and 60/63, and in 100 ampere single phase or three phase. The casing is normally cast iron type, but can be fabricated sheet metal design also. Such switches are suitable for mounting or on industrial type open switchboards only, and are available in both revariable and HRC fuses as shown here or here. Friends, we have already reviewed these revariable type three-phase distribution boards. Friends, I had been talking about the word circuit breaker. Let us define it. A circuit breaker is a mechanical switching device for automatic opening and manual or automatic closing of electrical circuits under abnormal conditions, having an adequate arrangement for quenching the fault energy. When the contacts come out, they create a fault. Uh, they create a arc which have a high amount of energy. So that energy has to be quenched. Normally, circuit breaker has enough protection against overload and short circuit, earth leakage, under voltage, and reverse power flow. But if occasion arises, it should have enough capacity to break and make the circuit in short circuit conditions. Circuit breaker may be classified from various angles as shown in table, which gives the breaking capacity of various type of switching unit. Friends, once again we are discussing over type of circuit breakers. The circuit breakers may be single or three-phase unit. That means in case of single phase 230 volts, and in case of three phase it is 430 volts rated. They can be of three types: miniature circuit breaker for loads up to 40 ton, then molded case circuit breaker MCCBs for meeting the load from above 40 to 400 kilowatt, or in case of ampere, in terms of ampere, 63 ampere to 630 amperes. Beyond that, we need a circuit breakers. Now, this is the type of uh, medium voltage circuit breakers. In case of 11 or 33 kV switchgears, we use minimum oil circuit breaker, vacuum circuit breaker, and SF6 gas circuit breaker. Friends, the figure on left hand side shows a typical configuration of miniature circuit breaker, or for that reason molded case circuit breaker MCCB of thermal magnetic type. The other type of circuit breaker are hydraulic types. So let us talk of this particular thermomagnetic type MCB or MCCB. Typically, they have at the bottom incoming circuit breaker and on the top outgoing terminal from which the current is taken out. Now you can take it like this, that overhead currents, over currents are dealt with by a bimetallic strip which has got two portions, one fixed portion and another is dynamic portion. So when this overcurrent is there, this contact system operates uh, and open up the circuit. Another is solenoid. Through the current passes like this. Here it travels like this, and then through this. Now this particular MCB has two braking spaces. One is here and another is here. So there is, when there is a sufficient short circuit in the system, that we take short circuit at 7 times the rated current. In that case, the current will flow and get heat will be generated here because it is 7 times rated current, and that heat has to be dissipated locally. So the arc which is created here in the electrical contact is the heat of that arc goes through this a large arc tube in which the current travels, takes a very lengthy space to travel, and thus the current gets thermally cooled and circuit broken. Friends, this particular slide we are using two features of miniature circuit breakers. One is their type of circuit breaker, and second feature used is advantages. So let us take them one by one. MCBs are manufactured with two different principles of operation. One is thermal magnetic and second is magnetic hydraulic. MCBs are manufactured with two different principles of operation, that is thermal magnetic and magnetic hydraulic. Now advantages of using MCB over such fuses. First advantage is MCCBs or MCCBs are essentially tamper-proof as they have enclosure of seal type. Second, MCBs afford closer protection than rewirable and HRC fuses in common use because of narrowly controlled tripping factor, that is ratio of minimum trip current or rated current, overrated current. Third, these are available in plug-in design also, in which case they can be pushed into circuit busbar even in energized condition. Thus, replacement is easy affair. Fourth advantage is they are modular in design, which permits their use in various combinations. In case of triple pole type, since they are gang operated, there is no possibility of single phasing. Next, MCCB can assume the function of switch as well as protecting device and consequently they may be used to control as well as protect circuit and apparatus. Friends, this particular slide shows the path of current travel in the MCB. It is like this. This is the incoming terminal, and after taking this route, it is taken to this solenoid, and from solenoid the current comes out like this. The MCB has got a dolly type switching device which if you put like this operates the uh, MCB. Now there are two systems here through which the current will get broken. One is the open, this one thermal magnetic type device over which current is overheated, then it gets operated, and another is this in case of shock circuit, a heavy current passes through the solenoid given here, which causes the circuit to get interrupted here. And when the circuit is interrupted, which is 7 times of full load current, a heavy arc is created. And for quenching that arc, we have the device here, which has got a very long route of voltage travel, which breaks this circuit breaker. Friends, this slide shows the type of MCB. This is one single pole. The other one is single pole and neutral combined. So this operates, when you operate this dolly, then both the neutral and phase current gets opened or made. The third one is a TPN type, which is used in motor circuits. It has all the three phases combined. And the fourth one is triple pole and neutral. This is triple pole only. This is triple pole and neutral. This one. Friends, molded case case circuit breaker MCCBs. These are similar to thermomagnetic type MCB except that these are available in high rating of 100 to 800 amperes at medium voltage, three-phase design also. In case of MCCB, thermal and magnetic relays are adjustable. In MCB, the adjustment is not possible. A shunt relay is also incorporated for remote tripping and interlocking of MCCB. Under voltage relays is always provided. MCCB are available with rating from 63 to 630 amperes, meeting a load of 40 kilowatt to 4000 kilowatt, but normally 2500 kilowatt. These are also of two types, thermal magnetic and fully magnetic. Different type of circuit MCCBs are shown in this slide. This is a single phase. This is a three-phase configuration, three-phase and neutral category, and some other categories. These are available 63 amperes to 630 ampere, thus meeting a load of 400 kilowatt approximately. Friends, TPN type distribution boards in bracket TPN DB are available in 4, 6, 8 and 12 way, each way having 15 amperes per way rating. Both they are available in two configuration, normal horizontal in width, vertical in height. A vertical TPN DB switchboard is a three-phase neutral distribution board used in above 100 ampere to 200 ampere capacity, in which the bus bars are outgoing devices are arranged vertically instead of conventional horizontal layout. This configuration is common in commercial and industrial electrical installation where space optimization, high rating and better segregations are required. The picture here shows on left hand side the four-way TPN-DB in horizontal configuration, and on right hand side shows the outgo eight-way vertical type TPN-DB 8-way. Friends, now we are discussing the horizontal type sub-distribution board or distribution force board DB. These are the combined busbar cum outgoing fuse boards provided for final distribution of electricity to various consumer circuit, normally installed very near to load or apparatus. These boards are also called SDB, sub-distribution board, or SPN-DB or TPN-DB. Distribution boards in TPN category are available in 2, 4, 6, 8, 10, 12 and 16 way 240 volts. SPN category, sorry. The DB is not merely an enclosure but a comprehensive system in itself, comprising of copper busbars, brass neutral links, earth links, and to facilitate effective distribution of current. The figure on right side shows 4-way TPN DV with incoming MCCB. This is a incoming MCCB, and these are three: red, yellow, and blue outgoing systems, each having four circuits, four wires, one, two, three, four. This is provided with a neutral bar. So when you are taking phase circuit from here, you take one wire from here and one wire from neutral. This is how a single phase circuit goes out from the board. Friends, this diagram shows a vertical type TPN DV. The TPN diagram has one number TPN MCCB at the bottom, that is here, and as a incoming main switch getting three-phase and neutral power supply from float AV or directly from MV panel of substation. And this figure shows 8 numbers outgoing TPN MCCBs, 4 on left side and 4 on right side. This one is one MCB connection outgoing, so like that 4 here and another 4 here, and this is the bus bar system from where the connection is taken to various outgoing switches. This system has got 4 neutral bus bars, 2 on either side, each having sufficient capacity to take the wire. To revise, Frank's circuit breaker, also called switchgear, protect electricity circuit from damage due to an overcurrent condition such as overload condition. It may be current overload or voltage overload, or a relatively high level short circuit fault condition. As I told you, the overload is normally taken as 125% of the rated capacity, and short circuit fault condition takes 7 times the normal full load current. Electrical circuits in residential, commercial, and industrial application usually include a panel board for receiving electrical power from utility source. Utility means electricity board. The electrical power is then delivered from the panel board to designated branch circuit supplying one or more loads. Typically, various types of circuit interrupters are connected to the branch circuit to reduce the risk of injury, damage of fire. Circuit interrupters include, for example, circuit breakers, contactors, motor starters, motor controllers, overload controllers, and receptacles having a trip mechanism. In event of an overcurrent condition occurs, electrical contactor within the circuit breaker will open, stopping the flow of electrical current through the circuit breaker. Similarly for the short circuit. Friends, we'll discuss now medium voltage switchboard panel. The medium voltage switch MV panel is always metal clad design. Components are housed in these separate earth metal compartments, that is breaker, busbar, cable and instrument. I've shown all the four on left hand side diagram. So let us take it. This is the instrument compartment, short one. It is shown here also on elevation. Both are elevation. This is front, this side elevation. Then we have a continuous bus bar system from here to here. This is bus compartment. Then we have cable compartments. There are, in this particular case, three cable compartments are so-called cable array are shown. 1, 2, and 3. The fourth one is breaker compartments. Here the various type of breakers are shown. These breakers may be MCB, MCCB, or ACB even. I have taken this diagram from Larsen to Blue. The cable array portion is shown in the plan also. A number of cables can be taken in or out. Compartmentalism. The figure on left hand side, friends, shows various configuration of laying bus bar in MV panel. This particular is a LNT design but was followed in previous years only. Friends, thanks for listening me and observing all the slides made by me for this particular purpose. Thank you.